In this video, you are going to learn about phase diagrams. What is a phase diagram? A phase diagram is a graphical representation of the physical states of a substance under different conditions. When I say physical states, for this semester, most likely you will see solid, liquid, and gas. And as for different conditions, for this semester, you will see temperatures. So as for the conditions, you are going to see temperature and pressure. Okay, let's look at a typical phase diagram. Over here, on the left side, you can see a typical phase diagram where you can see different colors and different lines. Over here, it is a gas phase or gas state. Over here, it is solid, and over here, it is liquid. The process of going from a solid to a gas directly without turning into liquid, directly from solid to gas, it is called sublimation. The other direction, the opposite direction from gas directly to solid, and it is called deposition. You may have already known this. From solid to liquid is called melting, and from liquid to solid is called freezing. So this one is the typical phase diagram of the majority of the material. Very rarely you will see it like this. This one is for water. So why do I say it's very rare? Because when you look at the line between solid phase and water phase or liquid phase, over here you see the line is inclining to the right side. Over here is inclining to the left side. So that is different, the difference. When the line goes to the left side, that means for the water substance, if you freeze the water, you are going to have a higher volume. That's why the ice floats on water. And there are other very special properties based on these phase diagrams. For example, over here, when you have a solid form, over here, let's say, begin over here. Let's say you begin with a liquid over here. At the same temperature, if you apply pressure, that means when you squeeze the liquid, what happens? It's going to become a solid. You can see from here, starting from a liquid, if you compress this liquid at the same temperature, after a while, it will become a solid when it is at a higher pressure. However, for water, it will be different. Let's say we start from here when it is a solid, and if you apply pressure at the same temperature, it will melt and become water. That's why if you have a piece of ice, and if you use a spoon or somewhere, try to press it on top, apply pressure, press it over here. Over here, the ice will melt. Once it melts, then become water and will allow the spoon to penetrate. And then once you release the pressure, the spoon will stick over here. It's just like welded together, because when you apply pressure, the ice will melt. The moment that you just release the pressure, it will freeze again. And now you have the spoon and the ice to become a single piece. Okay, let's look at how we can make, for example, if I start from a point over here, let's say, if I start a point over here as a gas, how can I turn this gas into a liquid? Okay, so there are many ways. The simplest way, it seems, that at the same temperature here, this is temperature, we just have to increase the pressure and it will become a liquid. Or we can increase the pressure and then drop the temperature. Now it is also a liquid. So based on this phase diagram, we will know two things. One is what is the phase under these conditions, certain pressure and certain temperature. The other information we can get is how we can transform from one phase to the other. How do we change the condition so we can get from one phase to the other? Okay, let's look at the phase diagram of carbon. Carbon, the most stable state at room temperature and under 1 atmosphere, it is graphite, that is the solid. Graphite is something that you can find from a battery, a AA or AAA battery. So when you buy a battery, you'll see the positive sign over here, negative sign over here. And inside this core, if you open up this battery, the alkali battery, you will see that there's a black rod over here, and that is graphite. Graphite, if you look around here, let's say we start from this point over here. Okay, how can I get graphite to become carbon vapor? Well, you can look at this. At the same pressure, you just have to increase the temperature. Okay, so now you can get into this phase, and that is vapor. How do I get graphite into liquid? Well, if you start from here, you can increase the pressure to all the way here, and then increase the temperature to all the way here. Now you can change graphite into a carbon liquid. More interestingly, probably some of you already seen the word diamond on top. So how can we make a diamond from this battery rod, this graphite? Let's say at room temperature, it is about here. And let's say at 1 atmosphere pressure, okay, let's say it's here. So that's 1 atmosphere. So how can you make from 1 atmosphere, starting from graphite, how can you make it to diamond? Okay, there are many different paths. For example, we can start from, let's say, room temperature. We increase the pressure, so it comes here, and then increase the temperature, so it gets here. Then increase the pressure, it gets here, and then increase the temperature, it gets here. Now we increase the pressure all the way up here, and then it would become diamond. After that, then I can drop, because it's still at very high pressure and high temperature. So I can drop the temperature back to room temperature and make it over here. And suddenly we quench it. Quench it means release the pressure very fast, okay? Or drop the temperature very fast. That is called quenching. And then we can quench it back. When it quench back, it does not have enough kinetic or enough speed to change the phase. So that's how we can make diamond like this. Is that the diamond that we wear as a jewelry? Most likely not. The diamond that people wear as a jewelry is from natural. This one is artificial. There are applications for artificial diamonds. For example, diamond is used in either in the sandpaper or to coat the blades for the saw to cut metal. Let's say if you want to cut a piece of metal that is very hard, or let's say you want to sand down the piece of metal that's very hard. How can we do it? We have to use something with a higher hardness in order for us to cut this metal. And diamond is known to be one of the hardest material on earth. The other ones can be silicon carbide and the other ones, but diamond is one of the hardest. That's why people usually on the saw blade, let's say this is the saw, the circular saw blade, it is coated with artificial diamond. So when the saw blade rotates, it can cut the metal. Okay, diamond It sounds expensive, but if people can make it in a big scale, it will not be that expensive, especially for the industry that used to coat a saw blade or sandpaper. They can make it relatively quite cheap. There is one point in the phase diagram that I would like to point out. That is the triple point over here. So what is a triple point? Either on this side, you can see one here, or over here, the general one. So let's use the water phase diagram. Over here, the triple point, it is consists of 3 different phases. Over here, you can see is right next to the liquid phase, right next to the solid phase, and right next to the gas phase. So what that is, it is a, let's say we have a beaker that contains water and ice together, okay? Because on top of it, you can see water vapor and water liquid and ice, they're all together. When the 3 phases are together, we call that a triple point.